I think I need to come up with like a good intro line or something that I always repeat. But anyway, welcome to the LabVIEW experiment. I'm your host, Sam Taggart from SAS Workshops. If you're a developer looking to unlock your potential and take your skills to the next level, then look no further. From freeing your imagination and experimenting with new ideas and workflows, to exploring aspects of software development you've never even considered before, I'm going to help you grow your craft so you can approach your work like an artist and have more fun with what you do. In my 15 years working with and training developers, I've helped dozens of individuals and organizations embrace a growth and learning mindset that allows us to overcome challenges and embrace failure as the essential learning experience it is. If you're ready for the philosophies, strategies, tips, and tricks that will unlock your creativity, then it's time to get to work. Welcome to the LabVIEW Experiment podcast. I am the host, Sam Taggart, and I'm sitting here with my good friend, Bill Welch, who I've known for how many years, Bill? At least 10. Well,
at least 10.
Well,
we met at NI Week.
So
the second year I was at Westinghouse.
It's 2022, and I left Westinghouse like 2013, 2014. So
it was 2012 when we met.
At least 10 years. Yeah. So yeah, Bill and I both worked for Westinghouse. I worked in Churchill, which is near Pittsburgh, and you were out of South Carolina.
Yeah, I was in Columbia.
Yeah, so we worked in different departments, but as often happens in large companies, we were both doing LabVIEW. We had no idea each other existed. I think was the first time we met at NI Week.
Yeah,
and you said,
I had
basically
been told by Westinghouse, by the people where I worked, that I was the only person in the company who did LabVIEW. And I walked downstairs in the hotel and I saw Bob Duay with the Westinghouse shirt, and I said, do we work for the same Westinghouse? And the next thing I know, he's introducing me to you, to Mark Samsowski, to Howie Doan was there that year, and Eric. And
wow, yeah, that's cool. Yeah, Mark is he's in Pennsylvania somewhere, I think.
Is he? I thought he moved farther north. His wife got a really good job, and he moved to...
Oh, well, I don't know. I know he was from Philly, and he moved there.
Yeah.
I don't know. Hopefully he listens to this. Give me a call, Mark, if you listen. I haven't talked to you in a long time. Mark's a cool guy.
Yeah.
Yeah. He was a very good LabVIEW programmer. Westinghouse had a lot of good LabVIEW programmers. We had several CLAs at Westinghouse.
Yeah. There towards the last, Eric and I were the only CLAs, and now there's no CLAs there.
Yeah. I remember when I got my CLA there, I was like, I don't think I was the first CLA in Pennsylvania, but I think there was like single digits or something. Felt pretty good. And then we got a bunch more at Westinghouse, and it became a lot more CLAs, and it was, a little less prestige. I felt a little bit less. I became a fish in a much bigger pond, I guess. Whatever size fish I was, the pond became much bigger. So
I'm not going to comment on that.
Yeah, that's all right. So
like most big, I'll just say that a lot of big organizations don't recognize the value of the people they got.
Yeah, that is definitely. But see, that goes back to my theory that it's all about the people, and it's about, we focus specifically in technological industries. We focus on the technology, and technology is certainly important, and it's a big part of it. But man, having the right people just, in my mind, makes all the difference, and treating them well.
Keeping them happy.
It's related, right? Because if you don't treat people well, they're going to leave, and the ones who are going to leave are the good ones, which people really fail to take into account.
Yeah. Well, I would just say that when situations happen and you need to work a lot of overtime, which, in our industry, sometimes things do go south and you have to work hard to make it right. If you're treating the people right and you just ask them for help to get it done, they're generally going to be right on board with it and do all they can. If you treat them like junk, they're not going to want.
There were definitely several instances I remember at Westinghouse regarding overtime. Not so much in my group, but I remember there was a group that was working overtime. They were making them work 60 hours a week for long periods of time, and they wondered why everybody was leaving. And they weren't paying them for the extra hours either. They were salaried or something, and they're like, you need to work 60 hours.
I found an interesting thing about salary.
Because
I worked for a company that would put you on salary so they didn't have to pay you overtime. And I found out that there's only a select group of people that can be on salary, and basically, if you're not in management and don't fit 2 or 3 criteria, I could have sued the company I worked for all the overtime, and they would have had to pay me time and a half for about a year and a half's worth of work.
See, I know overtime's one of those things where, like, when you force people to work overtime, and you're like, I feel like if you treat people well, you don't have to force them to work overtime. They'll work extra if it's needed to get the job done because they're happy and they enjoy it, and it's like not as big a deal. So that's
I mean, you're like me. If you're working on some code and it's the clock says it's time to go, but you're real close to finishing, you're going to finish it before you leave.
Yeah, generally, yeah. So yeah.
Anyway, unless you got something terribly important.
I don't want to turn this into complaining about big corporations because that could go on for a long time. But,
yeah. Well, that's not the purpose, is it?
No, not at all. But yeah, that happens sometimes. But anyway, the one nice thing I will say about Westinghouse is I got to meet people like you and Laura and Eric and Mark. And I learned a ton of LabVIEW, which was actually a really great experience for me in that respect. And that my boss bought me the training certification thing. And I was able to take all these classes, and I'm
the same way. That was a good thing. I got all my certifications at Lab, and I will say, and this is for new people to LabVIEW who may be listening to your podcast. If you take a certificate or you take one of the Core 1 or Core 2 courses or anything, find a project, dive into it, and do it. Because one of the reasons I got good at LabVIEW so quick is I walked out of Core 1 and Core 2 and had to do a project that the CLA should have been doing.
Well, I just had this conversation recently, and I can't remember. It was on one of the recent interviews talking about how, they call them programming languages, right? And if you think about languages, if you want to learn Spanish,
you got to immerse
yourself. The best way to learn Spanish is immersion. You can read all the books you want. You can do the Duolingo stuff, and that helps. But you really want to get fluent. You live in somewhere that speaks Spanish for several months, and you solve everyday problems using Spanish, right? Yeah. Like you go in a restaurant, you need to ask about the menu, you need to find the bathrooms, you need to go here, there, you need to get directions.
Right. I know I haven't spoken Spanish in 10 years or 20 years, and I can still ask where the bathroom is.
Yeah.
That one sticks with you.
But it's so similar. Yeah. When you talk about language, you want to learn Python or LabVIEW or whatever language you want to learn. You've got to do it regularly, and you got to solve real problems in it.
Yeah.
So, yeah, I think that's also how I did it, because I was just using it regularly. Like, so often you hear stories from people, CPIs, the people who teach the National Insurance courses, of students who take the course and then don't use it for 6 months or a year. And then their boss like, oh, well, you're the LabVIEW expert because you used it. You took this course 6 months ago. Go do this project. And by that point, they've forgotten everything.
Yeah.
I do think if you're trying to learn language, an artificial way to do that is to do things like Advent of Code, which I'm a very big fan of. Or when I was at Westinghouse and I was trying to learn LabVIEW and I didn't have immediate LabVIEW work to do, I would do the Euler project.
Yeah.
Or Project Euler or whatever it is. It's
I don't stay busy, and I've got code for 3 projects that I've done in the past. And of course, 2 of them I did, and I avoided Actor Framework because I didn't know a good way to manage subpanels in Actor Framework. I now want to go back and rewrite all 3 of those projects and use Actor Framework in them. 2, because of the way the project works, it's a perfect use for spawning sub-actors. I need to spawn eight actors and front panels or sub panels to be able to make the project run. The other one is the project that you and I were thinking about working on.
Oh yeah,
and I mean, they gave me the source codes because they wanted me to look at it. I still have them. Of course, I wrote it originally anyway.
Yeah,
and so it's just a perfect application to go into Actor Framework. So I'm like, yeah, I should probably just do it just to immerse myself into the Actor Framework better. And I'm more inclined to do it now with the toolkits that Casey created. That takes a lot of the magic out of the Actor Framework.
I have to say, I think that's a game changer. I just had a conversation with Alan, and we were talking about something similar, and like, So I don't want to bash on Actor Framework because I probably have done that a bit, and I am, full disclosure, I'm one of Fab's DQMH Trusted Advisors, but I have used Actor Framework. I've used it on a project. I thought it worked really well. It happened to fit that project really well, and I've written some tools to make Actor Framework stuff easier and more like DQMH. Nothing to the point where what Casey's done, which is just amazing, but.
Yeah.
Yeah.
Well, we actually were having a conversation today, Q and Casey and I believe it was. No, it was at lunch. Casey wasn't there. There were like 3 or 4 people there. But, we were basically saying that it would be really nice if they had a way to combine some of the testing tools like the message testers and all that you can script automatically with DQMH. They could incorporate that functionality into Actor Framework. That would be a game changer.
That's very interesting because I actually did that at one point, although it was back with the abstract messages, so I haven't went back to revisit it since interface.
Well, that they actually said that they had seen your tools and they were interested in trying to take those and.
That's why I've been talking to the AF Guild guys. So like they didn't put my name on the slide because I was like, I don't know, I'm like Fab's trusted advisor, DQMH. I don't know that I want to dip my toe into the Actor Framework world. And I've been rather critical of it lately, but I did talk to them because I wanted to make sure that tool didn't die because I put effort into it. And if somebody can benefit from it, I'm happy to help them import that. But my biggest thing against the Actor Framework, like I think it's a really elegant solution. There's a lot to like about it, but like just the trade-offs that it makes, I think certainly don't fit what I do, and I don't think it fits what a large majority of LabVIEW programmers do. Now, people are doing really huge, big systems. I think there's lots of advantages, and I think the people that you see who use it a lot and are really advocates of it, I think they're working on really large systems. At least that's my thought process, because like for what I'm doing, the trade-offs don't make sense, and I could see it making sense for big systems, and the people I talk to seem to talk about big systems, so I think that's the way. Yeah. But I think Casey's tool changes the trade-offs.
Yeah, it does. Yeah. It makes it easier. And I've always tried to be the balancing act in that thing where you got people who like this or don't like this. I think queued message handler, Actor Framework, DQMH, they each have their place. They each have a place where they shine, and you need to select the appropriate tool for the job. And that's all a framework really is a tool.
Yeah, well, I mean,
don't use a hammer where a screwdriver is going to work.
I've come to the point where I want to be opinionated and make a decision, but yet not be dogmatic about it. So, for me, my default right now is DQMH. If I see something where I'm like, hey, this would benefit from Actor Framework because I can see spawning lots and lots of stuff, and they're all so similar that the inheritance would really benefit me, I'd go use it, and I wouldn't have qualms about it. Yeah. If the people around me were comfortable with it, but that's the other problem is the people being comfortable. But I think that's where Casey's tool changes that because it lowers that barrier.
It makes it easier to become comfortable.
Yes.
That's one of the things that's encouraging me to try and do it because, I actually want to maybe take a different application the one application, the UT system, that's got so much going on in the background and all. It's Actor Framework is really perfect for spawning those actors and having them running asynchronously. And the other system where I have to do 8 sub panels, Q was telling me that use MGI Panel Manager. That takes care of all the under the hood working for you on that.
I looked at the MGI Panel Manager and I remember liking it. I remember thinking it was rather simple, which is good actually. I like simple code. And for whatever reason, I've just always recreated that code, which is actually probably a really dumb thing. I should probably just use what's there.
I'm learning that if you got, it's the whole purpose for writing our own reuse code for if you have a way you handle INI files, typically you probably got your own library written that you're using. That's the reason for doing that, because you don't create your own problems that you have to solve later typically. It's proven, tested code. Well,
there's interesting philosophies around dependencies and bringing in external dependencies, right? And some people are like, if it ain't written here, I'm not using it. I think that's a little bit hardline. But every time you bring in a dependency, though, you've got to keep it up to date, right? Well, I don't know that you necessarily have to, but if you find bugs in it and stuff, if it's not yours and you don't own it, it's difficult to fix it sometimes and get it addressed. And then you got to manage versions of dependencies. Although I guess, if you decide not to use, for example, INI files, you decide not to use the MGI read write anything, you write your own version of whatever it is. you still got to manage that as a dependency, even if it's an internal one. But at least then you have more control. Like definitely, I think closed source dependencies, I very much try to avoid. Like if it's open source, I'm okay with it because I know that I can always go get it. But one thing I do, and I don't do it so much in LabVIEW, but any other stuff that I do, if I use some open source tool, I almost always go and clone not clone, what's the term? In GitHub where you
get the repository and
and
get
fork.
the zip.
I always fork it. No, I just fork it. And so it's on my GitHub now, and I have my own. And that way, like I can pull stuff down, keep it up to date. But just in case, like it disappears.
Yeah.
I don't know that happens all that often, but there was the case that, speaking of dependencies, and there've been several cases lately, like in JavaScript and stuff, where like there was one where some guy got upset because they changed the terms and conditions or on GitHub or something. He's like, "I'm just taking mine down," and he just pulled it out. And like all these things depended on it, like broke the entire web. If you look it up, it's a very interesting story. Yeah. And so they were all depending on it, but they were depending on it, but they were just like pulling it down like as they needed it instead of like having a copy of it. And so when it disappeared, like they were just done.
Yeah.
Yeah.
That's a rabbit hole that we could talk about for hours and hours.
Yeah, well, we don't have hours. So, but anyway, so part of the podcast is LabVIEW Experiment. We're trying to encourage people to experiment, and we want to encourage failure, which I know where you're going to go with this because we just had this conversation, but like I want to encourage people to go try things. And if you're going to go try things and you're really trying new and innovative things, you're going to have failures where things don't turn out the way you expected.
So I think what you have to do is learn how to define failure. Because we've probably both worked for companies that were so scared of failure they would not even kick off a project. And, I would talk to management in those companies and say, look, I fully expect for the project not to work. If you want to use the term fail, that's fine. I don't define it as failing, but I fully expect it to work. Not to work the first
time, yeah.
Possibly, and likely not even the second time. But by the third or fourth time, it will work, and it will work well, because each time you make that attempt and it doesn't work and you debug it and troubleshoot it, you learn a little, you improve it, and you make it more stable, more solid. I mean, at the presentation I did today at GDevCon today, I don't know whether you were there, but I asked everybody, how many of you write code that works the first time every time?
Yeah.
And two smart Alex raised their hands, and I said, well, we got two liars in the room. And then I went
or two people who just haven't written much code.
Well.
Because you could get lucky once and then be like, okay.
So Alan Smith and Jeremy Marquis.
Okay, yeah. No,
yeah, they were.
Yeah, they're being smart Alex, yeah.
Yeah, they were being smart.
Yeah, they both have been known to do that from time to time.
Yeah.
Yeah.
But, I went and apologized to them later, and they said, you don't need to apologize for telling the truth. We were lying.
Yeah, no.
But, that's just going to happen. It's a learning experience. That's how you learn to write better code, and you should not be afraid for that to happen. You should act, Now, I will say this, that if you learn good processes, for example, unit testing, the amount of failures I have are tremendously reduced because I will say failures at the higher level.
Yeah.
Because I write a module to accomplish a task. I do my unit test. If it doesn't work, I catch it right then and fix it.
What do you do right then, though? You fix it, right? Okay.
I fix it right then.
I want to. So here's something else that I think we're afraid of, and I want to catch your thoughts on this. So I think sometimes we're afraid to throw away code.
No.
I feel like, because here's so you say you fix code. Often what I do, so I make a change and the unit test fails. I know something broke, right? So you say you go and fix it. But that requires debugging, right? So you debug and you go figure out what the problem is.
Yeah.
I found I don't do much debugging anymore, which is really weird. But I spend 30 seconds, I look at it. If I can't tell what the problem is, I go to Git and I just revert it. which is a total change for me because I used to do like you. I find the problem and I'd go fix it. To me, like,
well, we
but,
actually
so
had
I'm
that.
actually fixing it because then I'm going to go re-implement it again and make it work.
Yeah.
But like,
Yeah. So you and I had this conversation earlier this week too about debugging code. You said you don't like debugging code, and I told you my approach to debugging code.
yeah, no, I liked your approach. Yeah. So I'm really dumb. Like I'm a computer science. Well, okay, I'm not a computer scientist, but I've been studying a lot of computer science stuff, and I would like, if I have an input, I'm expecting some output down this big chain of event. I would start at one end and trace my way backwards, right?
Yeah.
Which is
that's a method, but it takes longer.
But yes, but how it did not immediately occur to me to do the binary search, like get bisect, right? Does the binary search and like
yeah, because
so, like, I knew that, and I've used get bisect, and I use that a lot, but it didn't occur to me to like. When you're tracing a signal to like immediately cut it in half.
Yeah. So, but that's one of the reasons I go ahead and debug, because I just wrote it. It's all familiar in my mind. That's the best time for me to look at it and say, okay, this is not working. I'm putting X in here and I'm getting Z out here, and that's not what I'm looking for. I'm looking for X and Y. Yeah. And so, you're going to
go through all the intermediate transformations.
All the transformations. Okay, right here in the middle. What am I expecting to see after these 2 or 3 functions, and probe it or something? Well, and what am I getting there? And then I know whether I need to focus back here.
Well, part of I think my rationale for doing it the way I do it is sometimes it's not always a clear correlation between input and output, and that path is not clear. So if you don't know the path, you're like, hey, I changed something over here. And this over here should change, but I don't know the exact path that the data flows, like off the top of my head. I don't have that visualization. Then starting at the end and going backwards makes a lot of sense because, like, it's easy to trace backwards. It's easy to look at the code and, there's an indicator there. Which sub-VI does that come from? Oh, it comes from that sub-VI. What is the output of that sub-VI? Is that what I'm expecting? Like, where am I losing the value along the way?
But the logic you just stated there is exactly the reason I debug immediately, because if I've just modified the code, the path and all is generally pretty clear to me at that point in time. If I wait 6 months down the road and make a change
no. So I think there's a difference there between I just made a change and I know I made the change and the change caused the bug versus somebody reports a bug 6 months down the road, right? Those are two different.
There is a difference.
Yeah. So in your case, what you're saying is if I just made a change, then debugging the code is easier because I've got that path in my head.
Yeah, everything's fresh.
Yeah, and what I'm saying is I agree with what you're saying. I just didn't have a different approach on those fresh bugs because I'm just like, hey, I changed this thing. It didn't work as I thought. Well, let me just throw it away and try again, as opposed to spending a bunch of time debugging. But, if you're fast enough at the debugging, so like I'll spend like, I set some time limit and I'm like, okay, I'm going to try to debug this for a minute, 2 minutes, whatever the time happens to be. If I can't figure it out, then I just get revert and try again. I don't know.
To me, it's worth the effort, even if I have to sit down and before I even start debugging, spend 30 minutes to an hour reviewing the code that I wrote 6 months ago that I've forgotten what I was thinking.
To find the path and
then do it.
Yeah, because it builds your understanding of the code. I can totally see that.
And like I say, basically doing that binary search, you're reducing your time because
you're reducing the search area every time.
You got here and here, and you say, okay, what am I getting here? Oh, it's right here, so now I need to be looking here, or it's not right here. I need to be looking here.
Every decision cuts the search time in half. And,
Well, in general, as long as you only got one problem. What if you got 2 problems and this comes right and you're getting it right here and you're still getting it wrong? Now you got to do the rest.
So I have a question. So I have that Git course I put together and all that. I went and I learned how to use Git bisect and stuff. Do you actually use that? Because my observation is that not many LabVIEW developers use Git bisect or even know that it exists or even have any idea of what it would be used for.
I don't. I mean, I took your course, but I focused primarily on the core functionality of Git for doing source control.
Yeah. So I don't know. I've had this project where I've been pushing changes, and I push the change, and I have ICI, and it shows up on the user's machine, or whatever. But we go several versions, and all of a sudden the end user will notice a problem. And she's actually very, very good about this. She'll be like, on version 2.4, this isn't working. And she'll say, I went back and it worked in version 2.1, right? So I've got my 2 endpoints for my get bisect. I could do a get bisect and test this condition at each one. But I actually don't usually get bisect. Like, there's been a few times when I've had to do that and go back. But typically what I just do is I just get diff those two things and say, well, what changed? And then generally from the changes, I can be like, oh, then narrows it down to this particular change. And it just becomes, so like in that case, I don't even like trace the signal. I just look at the diffs. I don't know.
And find what changed.
Yeah, does that seem like is that a reasonable? Well, I'm questioning what I'm doing just because I'm like, is there a better way, or like?
So, I used to work with a guy. I think I told you about him, that he would want something done, and his comment was always, "Oh, it's only 10 lines of code. It's easy. Do it."
Anytime somebody says "only," like I was talking to Dave Press about that. Anytime somebody says, "Oh, it's only this," you're just like, or just. You're just like, your hackle should go up, and she'd be like,
Yeah, to the point where I told him if he was so smart to just do it himself, and that got me in trouble. But anyway, I have seen it where you make a code change here that you don't think is going to bother anywhere else, and it blows everything up.
Yeah, it's weird. It's not a normal situation that happens, but it definitely happens often enough that you're like,
What in the world?
Well, that's kind of why you need the unit tests and the regression tests.
Well, you need the unit testing. You need to learn, the s'mores and solid principles and s'mores programming.
Yeah. Those things definitely help.
Because as long as you make sure that everything's very cohesive and loosely coupled, then you can change things, and if you change something and it breaks the code, you can usually go back to what you changed, and that's typically the problem.
Yeah. Yeah. But it's interesting, though, because there are certain things like, you talk about an actor framework project as a system of actors, or a DQMH project as a system of actors, and you get these like system effects where like these two things work perfectly by themselves, but you combine them, and somehow in their interaction in the timing or something, you got a race condition or something weird that then causes problems.
Yeah. I'm not sure I like the term systems. I do like the term that I heard used the other day. I was talking to an engineer who's rewriting a class, one of the advanced classes.
Oh, Jason. Yeah.
And he's using the term not really modules. A module would be a collection of what he's calling components.
Ah, okay.
And I like his way of thinking because it really helps you when you're designing a system to start to break it down. So I'll try and explain it in a way. Well,
you just use the term system, by the way.
Yes.
Okay.
So
just want to make sure
a system is a collection of modules, and a module is a collection of components.
Okay. Cool.
So
please. I'm curious.
Well, this is how I'm trying to reason it out and think it in my mind. So a test system. You've got a production system where you're running production. You've got a setup system where you're configuring and setting the test and making sure it's ready to go.
So that would be like your test system.
Yeah.
Like yeah.
Well, I'm actually referring to a project that you and I were thinking about working together. Okay. I'm using its model, and I'm being purposely vague because the company who owns it might not like all the details of their system going out there. But, you've got a system, you've got a menu system to go to different areas of the system. Then you've got a production system where you're actually running production and running test. You've got a setup system where you go in
setup screen.
And set up. You've got a calibration system.
They're all running on the same. So you're not talking separate systems as part.
Yeah. So the whole system is your system, your test cell. Let's call it. That's the system. Then you've got a production module.
Okay. Yeah.
And then you've got a setup module. Then you've got a calibration module, and you've got a diagnostic module. Okay. And each of those modules is made up of components, which are submodules that make it work. So
you got like a layered hierarchy, right?
Yeah.
So you've got the entire thing, and then you've got the high level modules, and then each of those has made up of individual components.
Yes.
Okay. Now, do the modules share components and share, or is it like actor tree type thing where like this module has its components, and if those components need to interact with something else, they go up through the module and come back down? And
so the way it was written 10 years ago,
well,
15,
this particular project, okay, yeah.
Yeah. The way it was written 15 years ago, some of the modules are shared.
Shared components, yeah.
Are shared components.
Yep.
For example, on the production system, you're gonna perform an ultrasonic test. So you're gonna access and control an ultrasonic test instrument and process the test. It also has attached to the system an X-ray fluorescent spectrograph for doing a metallurgical analysis that runs in parallel. All those are part of those two components are used in the production test system to do the test. But they're also used in the calibration system to do the calibration because what the calibration is doing is basically performing a test on a test article with known artifacts and making sure that it falls within your working or control limits. And then the test system or the setup system actually uses those, although it may use them a little differently because with it you use it to when you're switching over from one test item type to another test item type for a batch, you use it to configure the system to test that correctly. So those types of modules are reused all over the place. Hardware abstraction layer. We had to talk to an Allen Bradley PLC, which was the materials handling system, and we used the Ethernet over IP palette to do it. So we wrote a driver layer to do that. That was used, that driver layer, I guess you would call the I/O driver layer and the tag driver layer that we use for communicating with that that's probably more of a subsystem with modules than it is a component or a subsystem with components because
it's got several components underneath it.
Because in that instance, a component would be, okay, I need.
So you've got components, which are the low-level things, and then you've got a module, which is kind of like the messaging layer, right? So like your DQMH module or your actor, right? And it's got several components, so several things, maybe like hardware drivers that it's interacting with. And then you pull those together, and that becomes the system. And maybe there's like an intermediate layer of like a module that contains several sub-modules that then contain components.
And so, it's like this system that we're talking about, this is one of the systems that I would like to rewrite into Actor Framework.
Just to learn, just to clarify and practice these ideas.
To clarify and practice the idea of a system, a module, and a component, and to clarify, and plus that system really should have originally been written in Actor Framework, but at the time I wasn't qualified to do it. And
everybody
and
does the
Actor
best
Framework
they
had
can
not grown real big and wasn't popular then. It wasn't being advertised.
So for new projects now, then you default to Actor Framework, or you like, I think you said earlier, you just analyze the problem and see which one fits best. Is
that's what I try to do. I'm not doing that many big systems right now that would really require Actor Framework. That's why I'm saying I'm going to go back to some of the systems I've wrote in the past. And if I update that one system to Actor Framework, I may try to sell it to the customer who bought it.
There you go. Yeah, I've upgraded it. But you probably have to add some features to it, right? Because they don't really care if it's Actor Framework now, right? Like that's one of the things I was talking about with Jim Kring. Like, there's when you got to talk about you got to put
what's
your mindset,
the benefit to them.
the value. You got to sell the value to the customer. If you say, I took this thing, it was written in some old framework and it's falling apart, and now I rewrote an Actor Framework. What's the benefit? Now, It might not be adding features though. Like it could be like, hey, it was really hard to find people to work on that because nobody understood it and blah blah blah. Now it's better documented, so when you want to make changes, it's easier. So like,
yeah,
some that might be a benefit that the customer be like, oh yeah, well I really want to change this in the future, so thank you for doing that. That's worth something to me.
But the reality is, most of what I'm doing right now, the customer is doing test systems based around test stands. So I don't have a need to write these big LabVIEW systems. I'm basically writing driver layers.
Yeah, single VIs that are calling drivers.
That are being called by test stand.
Yeah, I haven't done many test stand projects lately, but the last one that I did was very much that. Yeah. So, yeah. Although, apparently, it's really interesting. There's some stuff with doing DQMH modules in test stand, and apparently they play really nice together. That was one of the things that Fab thought about when she designed it. I remember taking Alan's course, and there is a way to plug actors into test stand, but it's a little harder, and you have to do some shimming, and there's some weirdness there. Maybe that's gotten better since the interface stuff. I don't try to rack my brain to see how or if interfaces would change that, but it might.
Right now, my primary customer is testing PC boards used in medical devices, and they're basically, they're using bits to clock into a test and an acknowledge bit to say, yes, I'm there. So just straight digital. Mm-hmm. I can write one digital read and one digital write VI, and I don't have to write anymore. It just works.
Yeah. No, that's nice.
So
simple is always better, I think.
Yeah, and it's very simple.
If it works.
That they're measuring some currents, measuring some voltages. The hardest thing I did on the first project with them was it had a piezo buzzer, and they wanted to make sure that its noise level was 75 dB. So we got an analog card, wired a microphone into it, and used the sound and vibration toolkit to do the measurement analysis. But it's almost impossible to convert from a microphone to decibel. So what we had to do, there's a calculation, and the problem is it's a nonlinear calculation to convert from decibel to sound pressure.
Oh.
So the output of the VI I was using was sound pressure. And
yeah, I'm not an audio guy, so I don't know too much about that. I mean, I know what decibels are, but I don't.
Well, fortunately, I was working with some really good firmware engineers and really intelligent engineers, and they sat down and said, okay, here's what should be. And they actually had a sound meter that.
Well, could you calibrate it? Could you just have like something that is a calibrated source that produces 75 decibels, and then just say, well, that generated that much pressure, and that's our limit?
I'm sure you probably could. I mean, I've done that with thermocouples. Fluke used to make a thermocouple tester where it would send a signal to your wires that says this is 100 degrees, and you could make sure that you were reading 100 degrees and calibrate your system.
Yep.
So I'm sure you probably could.
Yeah, I'm not an expert on calibration stuff. I mean, I've done a little bit over the years when needed, but yeah.
I had the opportunity of working with Eric on a project where we had to do a lot of calibration. We had to calibrate stuff. We had to calibrate load cells and accelerometers for the test that was going on. And we just wrote our own VI. We would plot capture the data points on a graph, and then run the VI that did the calibration and gave us our results. Going back to your point, to encourage people to experiment, I've had this conversation with a number of programmers. I think maybe you and I were together, and I asked it. How many of us sit down and do what I call play in the sandbox code? You have a task, you've never done it before, and you want to figure out how to do it. And you sit down and you start experimenting, writing code, and usually it doesn't work the first time.
Yeah.
It takes 2, 3, sometimes 10 or 15 tries to get it right.
Yeah.
But you eventually get it right. Does that mean that each of those tries between the first and the 15th, if that's how long it takes you, is a failure? Or is the project a failure if you're not successful? The project's a success if you figure out how to do it and it works. Those steps up between there, those are learning experiences, not failures.
Maybe even better though, you figure out that what you're trying, like the way you're trying to do it is not achieving what you want to achieve, right? Because you got to focus on the bigger picture goal rather than like the task. Like part of my conversation with Jim was about that, like figuring, like diving deeper and saying, okay, like this is like, how many times on the forums or something does somebody come up and say, how do I do X? Right. And it's always very technical. Like, how do I pass something out of a loop and do blah, 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 like whatever it is. And I'm stumbling to come up with a great answer here. How do I filter an array in, right? Yeah. Or something like that. And I'm like, well, what are you trying to accomplish? Yeah, what are you trying And you find out that they're trying to do something completely different. But like that was just one of the steps that they were using. And like that step had them stuck. But what they were originally trying to do, you didn't have to filter the array. You could do something completely different and work around it.
I mean, I'll give you an example. One of the projects I worked on, I was going to write firmware to a PC board for a company. They would connect it. We would connect to the PC board, read the version, read the serial number, all of that, and say, okay, what version should it be? Is it up to date? No. Well, then let's do an upgrade. Well, that firmware had to be sent over a serial port, which serial's not a problem for me, using X modem protocol.
Huh.
That was an issue. I've never, I'm like, it'll take me forever.
I have no idea what X modem protocol is. I've heard of it, but like.
Yeah. Well, you can go in and read the specs, and after falling asleep 10 or 15,000 times while you're trying to
Is it like a protocol like on the physical lines, or is it like at the level of like the format of the text you're sending?
Yeah.
It's at the format of the text. Okay.
And so what I did is I started researching it because I had, honestly, I had no clue where to even start to write that protocol for a serial port in LabVIEW. And what I found is some kind person had written it on and put it on the LabVIEW website. Wow. So I was able to download it and put it in my project. But then I ran into the issue where it worked on 3 of the 4 versions of the board. And on the 4th version, it kept failing when you burned the firmware. And, I'm like, okay, why is it working on these 3 and not on this one? And, bought a serial analyzer and pulled it out and started looking at it, and come to find out, for some reason, on this one file that we were sending, one version, it was adding a couple of bogus characters.
Huh.
And I found out.
What was that, the driver that you were using?
It was the driver that was doing it. And so I dug into the driver, looked, and found out what was adding the character, and I removed it from the driver.
It worked.
And recompiled, and it worked on all 4 boards. And I'm like, well, I don't really understand why that works now, but it works, and it's not failing.
Well, that goes back to our discussion about dependencies and pulling in dependencies, and then suddenly you're responsible for whether it works or not. And but at least that was open source so that you could dive down into it, right? Imagine if it had been a closed source thing and it's just randomly adding those bytes, and then you're kind of stuck. Like, what do I do? And then you have to go either re-implement it all yourself or find a different.
I found most companies seem to be very flexible. The last project I worked on, doing the medical boards, the company wanted to make sure the boards had the latest firmware, and it was an 8-socket test station. Mm-hmm. So they bought a programmer. It was a 4-gang programmer that could be serial daisy chained. So they bought 2 of them, daisy chained them together, and I had an 8-gang programmer. And that company had DLLs that could be called from LabVIEW, and they actually had LabVIEW drivers for those DLLs, which was great. And it would not work. It kept bombing on. It's been so long. I think it was on the initialization portion. And so this company had super technical support, but I called them and I started talking to them about what was going on, and they identified the problem. They said, do you have the header files and the C files for the sort code for our DLL? Yes. Go into this header file, go to this line and edit right here, save it, and it'll work. So, I mean, even though that was proprietary stuff, they told me how to go in and fix it and make it work.
Interesting. Yeah.
And I'm not a C programmer. Without their help, I'd have never figured it out.
Yeah, I do very little with C and very little with DLLs. So I'm not, I'd like to learn a little bit more about that, but can't learn everything. So
I have written a few LabVIEW DLLs. I actually wrote a .NET interop assembly in LabVIEW some years ago.
Yeah, I've played around with .NET stuff here and there. I don't know. You and I have had this conversation. I'm very much an anti-fan of Windows, and I would love nothing more than to never use it again and just do everything in Linux. So, although I mean, Linux has shared objects, which are basically DLLs anyway. So,
but let's be honest.
Thing.
I fully acknowledge that Windows has its problems. It's just that I've been forced to use it most of my adult life, and I'm more comfortable with it than the other ones.
I think part of the reason I don't like it is the rebel in me hates being forced to use it. That, like the fact that like all these companies like you must use Windows and they don't give you any choice. And so if I had a choice, I don't know, I might choose it, but I kind of doubt it. But
It's got its problems, that's for sure.
Well, I mean, for the longest time, like it was basically the choice was Windows or Mac, because Linux was more for like the aficionados, I feel like, and now it's gotten polished to the point where like you saw like Ubuntu or Pop OS or something, and yeah, it's not Windows, but like the desktop experience is very similar and close enough that you can kind of stumble your way through it. Although Linux, at some point, you have to learn command line because like that's just part of it,
But yeah.
Well, I feel like Linux is gaining ground partially in our world of like LabVIEW stuff,
well,
partially because of C-RIOs.
Gaining ground because of the real-time target.
Yeah, exactly. So if you have to learn Linux and learn all these Linux command line stuff for C-RIO, which like, you have to, if you're going to use a C-RIO, you have to use Linux RT and you have to learn the command line. Then you can transfer those skills to a desktop and a lot of the commands are the same and the navigation and everything. And yeah, I kind of got into the whole Linux world when I left Westinghouse, actually, because one of the nice things about working at a big company is they have all the infrastructure. So at that point, I was working with Eric. We were using SVN and Bugzilla, and I started on my own. And like I didn't have an SVN server, I didn't have a Bugzilla, and like I hadn't stumbled upon GitHub yet that I could just like use them to host everything. So I set up my own servers.
SVN is free. You could get a copy of SVN for free.
And you could do local repositories with SVN, like Taurus SVN or something. But if you wanted to store them on a server somewhere, especially if you wanted something that like you could share with your clients, right? So if you wanted to have like svn.sasworkshops.com and I wanted to be able to give you the URL so you could check out my code or clone my repo or whatever. I forget what the SVN term was. Checkout, I think. Yeah. Well, like, I couldn't do that without setting up a server. And then I needed to learn some web stuff and I need to learn, and I had to set my own websites. I had to learn about domain names and registering domain names and DNS records. And like, there was just a ton of stuff to learn there. And part of the learning of all that was learning a lot about Linux and running stuff from the command line. And which is a useful skill. Yeah. But I had a conversation, and I think it was with Jim, because we were talking about CI stuff and all the things that you have to learn to get CI stuff set up, right? You have to have a LabVIEW project. You have to know LabVIEW, right? So you want CI to automatically run tests and build a LabVIEW project. Well, you need LabVIEW. You need to write the code. You need to write the unit tests. You need to know how to write unit tests. Then you need to figure out how to run all of that from the command line, right? Using Git Bash or PowerShell or however you're going to do that. Then you have to learn how to do the YAML stuff to get it all set up in your GitLab CI file.
I thought you were using a GCLI.
Or GCLI, yeah. Sorry, I use GCLI. Well, I used to use LabVIEW CLI for a little bit, but yeah, GCLI. So you got to learn GCLI and how that works. And
GCLI ships with the Goop toolkit, doesn't it?
That I do not know. It might. It's James McNally Wiresmith thing, so it's a separate. But anyway, so that's just to get that. But then you still have to know about virtual machines because you have to set up your own virtual machine with the runner, and you have to know how to install the runner software and run it as a service or run it as a user, and you got to connect it, and you got to share the API keys, and there's like a ton. You and I had this conversation about trying to set all that up, and there's a ton of stuff. Yeah. I do have a video. I think it's on my YouTube channel where I walked Casey May through set, and I think it was just setting up a runner, so it's just part of that. But but there's a lot of gotchas and like stubbing your toes along the way, and like it's like walking around in the dark in an unfamiliar apartment.
A start to finish video. This is how I'm doing my CLI, and just start to finish, starting from scratch and setting it up would be a good video that people might pay for or want to see. Or,
well, Jim and I were talking about that though too. Like there's certainly utility in that. But part of the thing is everybody's system is going to be slightly different because some people are like, I use GitHub, I use GitLab, I
use Jenkins, I use Azure.
I prefer LabVIEW CLI over GCLI, I prefer Git Bash over PowerShell or whatever. And there's all these little variables and little like, and none of them are necessarily right or wrong decisions. Like there's different trade-offs, but it
amounts to what you're comfortable with.
Yeah, but it makes it really hard to say, here's the recipe to do it, because if you're not like, if I give the recipe, I use Git Bash instead of PowerShell because I like Linux much better and I never bothered to learn PowerShell. So if I give it to you and you don't understand Git Bash and you rather use PowerShell, that throws a thorn in the works. Yeah.
That's one of those areas where you would have to say, well, here's what I'm using and here's what I do. You're going to have to figure out how to do this in your system if you're going to use one of these.
Well, even some of the things like, like setting up virtual machines. Well, there's, I use KVM now, but I used to use VMware, and there's VirtualBox, and there's.
Does KVM play as nicely with USB ports as?
It does play nicely with USB ports. You can redirect USB ports.
Is that only Linux, or is it a?
It's a Linux thing. It's not as nice. I have to say, as VMware, it's not as polished, but it has all the same features.
Cloning and copying and all.
Yeah. I mean, I just got, because I got a server to run all my VMs for my CI stuff, and I didn't want to pay for a VMware vSphere license. So I was getting tired of, like, every time I bought a new workstation, I had to buy a new VMware license because I liked the Workstation Pro. And it was kind of getting expensive and a pain in the butt. And I was like, I'm running Linux anyway because, once I switched to where I was using a virtual machine for every project, that was where I was using Windows 10 at the time and still using Windows 10 because I needed to run LabVIEW and all that stuff. And that's what my clients were using. But once it's a virtual machine, like the underlying OS doesn't matter.
Yeah.
So then I started using Linux and I was like, well, okay, I'm using Linux. Why am I paying for VMware? And it runs on Linux and it's fine, but KVM is free.
That might be worth
we're like getting way down into the weeds of like detailed
Linux
stuff.
On one of my servers so I can run a free VM because I don't. VMware is expensive.
Yeah, it's a nice polished thing, and I have no problem with it. But for like home use, I say home use. It's it's my business, but it's like it's not like I'm not some big enterprise. So for my use level, like paying for a VMware license, and also VMware comes with limits. Like there is a free VMware vSphere or ESXi or something, but it has limits on how many virtual CPUs and how much RAM, and like KVM, no limits. But part of it not being as intuitive is like there's a GUI, but it's not as nice. And then you do a lot of stuff in the command line, but I've got it all figured out and I got it worked out and it works pretty nice. And I'm happy to show it to you sometime.
How's the performance?
Performance seems pretty good. I haven't noticed anything, but I'm not doing anything super high performance. Is this off topic
from your podcast, by the way?
It's very much off topic in a way, but in a way, part of the podcast is to encourage people to experiment and try different things. So trying different things, if you're used to using VirtualBox, switching to VMware, and I also want to bring in outside ideas. Yeah. So the idea of using VMs, that might be new to a lot of LabVIEW developers because there are some people who aren't doing that.
Well,
I talk to them all the time.
So my explanation for VMs, I use VMware and I create a virtual machine for every customer. Not every project because like this one customer, they keep giving me projects. I do about one project for them for a year, but I'm always building off their previous project.
Yeah, and they standardize on a particular version if they're like clients often do that.
But, somebody else comes, I'm going to create a new VM with the version that they want to use. And because the driver situation with LabVIEW is that, I don't know whether there's a solution for that.
I used to do a new VM for every project, and then I started running out of server space. And then I realized that for a lot of projects, if they're not installing third-party drivers, then a generic LabVIEW 2020 VM, 32 or 64 bits with the standard DAC MX drivers works for a lot of projects. And so I started just doing that. And then if I need to install third-party drivers, then I will create a new one and do that on an as-needed basis.
Yeah.
And it's cleaned things up a lot.
But I also use I use that for all my LabVIEW because I didn't find, I've tried VirtualBox. I didn't find it to be play nicely with USB ports. I tried Hyper-V. I use Hyper-V on another server, but I use it only for financial software and all. But it doesn't play nicely. And when you're doing the USB DAC and all that, you're stuck.
Yep. No. I would love to continue this conversation. We could go way down the rabbit hole of VMs, but unfortunately, as you mentioned, it's not entirely on for podcasts. It's not far off, but also we have a limited time, so I don't want to bore podcast listeners with like hour-long podcasts. So we'll.
So I'll sum it up for one thing. Don't be afraid to experiment. That's how you learn.
There you go. That should be the tagline for the podcast right there. So thank you very much, Bill. It's been a great talking to you.
Great talking to you, Sam.
That's it for today's episode of the LabVIEW Experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at @TheLVExperiment so you never miss an episode. And remember, small steps and quick feedback are all you need. Catch you next time. All right, cool.
Good job.
Yeah. Yeah, I actually have to watch that. I forgot for a second that I was being like videoed. I turned to you and I was like, oh.
Oh, no, it's okay. I was just trying to make sure you knew I was there.